Okay, as I said, I posted a file. The title of the file is Simple Regression Class.rmd. We now go to an example of application of data science. So what we have done so far were to learn how to use data visualization and data wrangling, making use of ggplot2 and dplyr. Now we learn an application of data science. So after you visualize data, after you wrangle the data, you identify those variables that you need for your analysis. We learn a very a simple example of data analysis, and that is regression. So I hope you were able to access the file that I presented or I uploaded in our Canvas. So we're going to learn simple regression today, and on Wednesday, multiple regression in another lesson. Okay, so what's simple linear regression? I already did some notes here to facilitate our discussion. Now, when we talk of simple linear regression, we would like to explain a particular variable, let's call it y, which is called usually the outcome variable or dependent variable, in relation to another variable called the independent variable, x. So we're trying to explain, we would like to learn more about can you hear me, guys? Okay. We'd like to learn about the properties or the qualities of this variable y in relation to a predictor or independent variable called x. It's called simple because you only have one independent variable or predictor variable. You're only using one specific independent variable to try to explain your dependent variable y. So in a simple linear regression, what we'd like to learn is to understand how your y, your outcome or your dependent variable, relates to your predictor variable or your independent variable. So the goal is to be able to establish a mathematical model, or a formula, so that we can define y in terms of our x or our independent variable. Okay, so that's one objective of simple linear regression. Another objective is, as stated here, once we have built the statistically significant model, take note I said statistically significant model, because if it's not statistically significant, then we cannot make use of that model to predict. Okay, we use that model that we build up through the simple linear regression in predicting future values of y, okay, given new values of x. So let's write here for predicting future outcome, or that's your y, future values of your outcome variable on the basis of new x values. Okay, so for example, we'd like to predict what will your y value be given a particular value of x. So simple linear regression is used for that. So not only for explaining more your outcome variable y, but it's also used for predicting x values. Okay, so what we're going to consider now is we're going to use a data set that comes from Datarium, and we're going to look at the impact of advertising budgets of three medias, YouTube, Facebook, and newspaper, on future sales. Okay, so we'd like to establish a relationship between sales and this YouTube, Facebook, newspaper. Okay. However, notice that we will have to look at this one at a time. YouTube first, and then I leave you as an exercise to look at the relationship between Facebook and sales, and then newspaper and sales, because what we're doing is only simple linear regression. Next Wednesday, we're going to do multiple linear regression, where we're going to combine all of these three predictor variables in trying to explain your sales. So the main difference between a simple linear regression and the multiple linear regression, okay, is that for a simple linear regression, you're only using one independent variable to try to explain your dependent variable y. All right. Now there are certain assumptions that need to be recognized in a classical linear regression model. Okay. So these are the assumptions which we're going to look into as we discuss this. Number one is that the regression model is linear in the coefficients and the error terms. So that means the coefficients, your betas, which we're going to discuss, should be linear. Okay. Also, the error terms, once we produce the model and we compute for the error terms should be linear. Number two, the error term has a population mean of 0. So if you get the average of the error term, it should be equal to 0. Next, all independent variables are uncorrelated with the error term. So if we plot the independent variables with the error terms, there should not be any relationship between them. Okay, if there's a relationship between the error terms and your independent variables, then that means you were not able to capture that relationship in your model. So that's a very important assumption, number 3. Number 4, all error terms are uncorrelated with each other. So if you look at the error terms, there should not be a correlation or what we call autocorrelation between them. Okay, and this is more applicable to a time series, because in a time series, the data is arranged chronologically. For a cross-sectional series, this is not relevant, because for a cross-sectional series, you can change the order of the appearance of your observations or of your data. The number 4, observations of the error terms are, okay, I've finished this. Number 5, the error terms has a constant variance. So which means that there should be no heteroskedasticity. Okay, this will be seen when we plot your error terms. Number 6, no independent variable is a perfect linear function of the other explanatory variables or IVs, which means that the independent variables should not be related to each other. Okay, and number 7, the error term is normally distributed, but this is an optional requirement. Okay, so some notes here. Now, the formula for a simple linear regression follows this. Okay, let me put this in the second line. Y is equal to beta null plus beta 1 times x. Your y here is your dependent variable, and your x is your independent variable. So notice that this is the equation of the line. This is an equation of the line where b sub o is your intercept, okay, which is the predicted value of y when your x is 0. Okay, because when x is 0, therefore this cancels out. So your y is equal to b sub 0. That's your intercept. On the other hand, b1 is the slope of the regression line. Now, how do you compute for bo and b1? Okay, we use what we call a method called least squares. Okay, this one, least squares regression. Let me highlight that. It's called your least squares regression, or OLS, ordinary least squares. Now, what happens in OLS, or ordinary least squares? What is done here is that you get the residuals. The residuals is the error term, or the difference between your actual value and your predicted value. And then we square it. We square the difference between the residuals, which is the difference between your actual value and your predicted value. We have to square that because if you add those residuals, the sum will be equal to 0. So we square it. And then after squaring it, we add everything, the squared residuals, okay? and then and then we choose that which will give us the minimum value of your residuals squared. Okay, we'll discuss this in greater detail once we go to the model. Okay, then we don't just stop with determining B sub O and B sub 1. What we have to do is also to test, to check whether the values B sub 0 and B sub 1 are statistically significant. So we perform what we call a t-test. Okay. A t-test in order to determine if the values generated for B sub 0 and B sub 1 are statistically significant here. Okay. A non-zero beta coefficient are significantly different from 0. And when that happens, it means that there's a significant relationship between the predictors X, in our case, the predictor X, because we only have a simple linear regression model, and the outcome variable Y. Okay? All right. It's best to learn this by an example. So may I request you to please load these packages if you're following along. Now, I think the new packages here that I'm putting in is ggpubr. I'm not sure if we have already installed ggally and Datarium and Cable Extra. We're going to make use of them later on. Okay, so if you have not done so, guys, I'm going to give you a few seconds to install. If you have not installed this, just write here in your console, for example, install.packages. You can write your installation code here. And then, for example, it's ggpubr. Okay, you can do that. And then enter this. Okay, and also with the other packages. Okay, I'll pause for a while, guys. Okay, I'll give you a few seconds. I'll pause this. Okay, I hope you were able to install the packages already. Okay, now we're going to make use of a particular data set that comes from the Datarium package. And we're going to use the data set marketing. So the code is this one, data marketing from the package Datarium. And then let's view the data. And then let's generate the first 10 lines of the data. So if I run this, okay, then view. Okay, so this is what the data marketing consists of. Okay, you have here YouTube, Facebook, newspaper, and sales. This is the budget for YouTube, the budget for Facebook, the budget for newspaper, and the budget for sales. Okay, I'm sorry, I forgot to check what's the dimension of this. I know that the YouTube, Facebook, and newspaper are in thousands. I'm not sure if sales may be in millions. Okay, so this is our data set, and we'd like to establish the relationship between sales and YouTube, sales and Facebook, sales and newspaper. But we're going to do this one at a time because we'd like to learn first simple linear regression. We can do this all together, where we're trying to establish the relationship between sales and those three predictor variables, YouTube, Facebook, and newspaper. In that case, we will be using multiple linear regression. But let's start first with simple linear regression. Okay, so let me run this head first 10. Okay, so these are our first 10 observations: YouTube, Facebook, newspaper, and sales. Okay, let me just remove that. All right, so our research question is, actually we have 3 research questions. The first one is that there is no relationship between sales and YouTube budget. Okay, oops, sorry. Did I continue recording? Okay. So there is no relationship between sales and YouTube budget. And also there's a relationship between sales and YouTube budget. We're going to answer this, guys, and then I leave you as an exercise to answer this second research question and the third research question. The process will be the same, okay? But of course, this is a very inefficient way to do it because we can actually do this all together in one process called multiple linear regression. But we're starting to first learn simple linear regression. Okay, we're going to start with the first research question in that we'd like to determine the relationship between sales and YouTube budget. Is there a relationship between sales and YouTube budget? That's the research question we'd like to address. So how do we do this? Before we answer that question, let's plot those four variables: sales, YouTube, Facebook, newspaper, and data is from marketing. Let's see how they are related. Okay, so let me run that. Control Enter. Okay, so we find here the plot. Okay, between sales and YouTube, sales and Facebook, sales and newspaper. Okay, first, let's take a look at the relationship between your dependent variable or outcome variable or predicted variable sales with YouTube, with Facebook, and with newspaper. Okay, so where do you find that relationship? Okay, you can find it here, sales with YouTube. Okay, so there seems to be a linear relationship, okay? Linear relationship between sales and YouTube, okay? And that's good. If there's a linear relationship between your dependent variable and independent variable, that will be good for your model. How about sales and Facebook? So you can look it from this plot or from this plot. Okay, what's the difference between this and this? Sorry, this plot and this plot. Okay, in this plot here, your y-axis is your sales and Facebook is your x-axis. However, in this plot, okay, your sales is this one, so that's your x-axis, and your Facebook is this one, so that's your y-axis. For our purposes, guys, and the practice is that the y will be your dependent variable, and then the x will be your independent variable. So in our case, this is a plot that we're interested in. So sales as your y-axis, and then Facebook as your x-axis. Okay? Now, on the other hand, this is your sales and your Facebook. So this one, sales, Facebook, YouTube, I mean, YouTube is your x-axis and sales is your y-axis. So we can also see that there seems to be a linear relationship between sales and YouTube. As we mentioned a while ago, sales also and Facebook seems to have a linear relationship, although it seems that sales is more linearly related to YouTube than to Facebook. And then to newspaper, sales and newspaper, we find that there seems to be a very weak relationship between them. You don't seem to see there seems to be a very weak trend, okay? The data seems to be going up. Sales seems to be going up as newspaper goes up, but it's not as apparent as sales and YouTube, okay? So after looking at the relationship between your dependent variable and independent variable, what you need to look at also is the relationship between your independent variables. Now, we don't want our independent variables to be related or correlated to the other independent variables. So for example, this one, is YouTube related to Facebook? Okay, it looks like there's no linear relationship between them. The data is scattered randomly. Okay, no apparent trend. So is this good or bad? Okay, that's good as far as our linear regression model is concerned, because we don't want any relationship between your independent variables. We're going to use YouTube as an independent variable, and so is Facebook. And if they're not correlated, then that will be good for our model. Okay, how about YouTube and newspaper? YouTube and newspaper, also the same, no, there doesn't seem to be a strong relationship between them, which is also good. And then Facebook and newspaper, here there's a little bit of a trend, but not that much, okay? Facebook and newspaper. So it seems like the use of YouTube, Facebook, and newspaper will be good as far as explaining your dependent variable sales is concerned. It will be good because the independent variables are correlated or show a strong correlation with your dependent variable sales, but the correlation between the independent variables among themselves is weak. Okay, so that's good. That's what we're looking for. Okay, so going back to our model, there's another way to plot the correlation. GG pairs is a very good way to plot the correlation, and this is coming from GG Ally package. So let's plot this. The code is GG pairs and then marketing. We use this because we'd like to, since marketing consists of your sales, YouTube, Facebook, and newspaper, just like this. Okay, so let's plot this. Okay. So if take a look at this one, guys. Okay, it already gives us the correlation. Okay, correlation between your variables. Okay, let's take a look at this. Now it appears in this way because our marketing data. If you take a look at our marketing data, okay, YouTube appears first, then Facebook, then newspaper, and then sales. So the correlation plot is also presented in the same order. Okay, so let's take a look at our correlation. First is correlation between sales and YouTube. Sales and YouTube, the correlation is 0.782. And the 3 stars there indicate that it's statistically significant. Okay, so we're certain that we can conclude, we can infer that the correlation between sales and YouTube is not 0. So that's what this means. In fact, it's 0.782, which is quite a strong correlation. Remember, guys, your correlation ranges between -1 and 1. A value of correlation close to -1 indicates that it's strong negative correlation. And a value very close to 1 means it's strong positive correlation. If it's a value very close to 0, then it means that it's not correlated. A bit near 0, it means that there's a weak, either positive or negative correlation. So from this GG pairs plot, okay, remember this is GG pairs. From this plot, we see that the correlation measured between sales and YouTube is 0.782, positive. It's a strong. It's indicative of a strong relationship between sales and YouTube, which we said a while ago, guys, is good because we want the relationship between your dependent variable sales and your independent variable, in this case, YouTube, to be strong. Also, sales and Facebook, it's also strong, but it's not as strong as YouTube. And we saw that in our plot, right? We saw that in our plot, sales and YouTube here, okay? On the other hand, sales and okay, Facebook, okay, this one, not as strong as that of YouTube, and newspaper also, which there's a weak correlation between sales and newspaper, 0.228, and a relatively strong correlation between sales and Facebook. But the strongest relationship is between sales and YouTube. And we can guess that YouTube will be, among the 3, will be the best predictor for sales. Okay. All right. So now let's have a clearer picture by drawing a scatter plot between YouTube and sales. Okay, let me modify this a bit. Let me start with marketing. Let's use dplyr, marketing, and then shift. Okay, so let's use the pipe operator. So from marketing, then we do ggplot, then I remove this. I remove the marketing here because we already defined it coming from marketing. Okay, to plot your scatter plot, we use the GM point and the GM smooth to show the confidence interval. So the formula is X is equal to YouTube. Okay, that will be our independent variable, and Y is equal to sales, then plus GM point, and then stat smooth. Okay, so let's run this. Okay, so here we have, guys, the relationship between the plot, the scatter plot between sales and YouTube. Okay, and this is the regression line. Okay, and the gray there is your bandwidth, your 95% confidence interval. Okay, but we notice that our data seems to be the variance of our data set seems to be increasing over time. We might have a problem with the heteroscedasticity here later on when we diagnose this. Okay. All right, so this is the plot. This is the scatter plot of your independent variable YouTube and your dependent variable sales. Okay. All right, then we now go to our regression. Okay, for this one, we actually have already computed for this, the correlation. Okay, just to check. So this function, as I mentioned a while ago, correlation measures the level of association or relationship between two variables, X and Y. The value ranges from -1, which means perfect negative correlation, which means when X increases, then Y decreases. And +1, perfect positive correlation, which means that when X increases, Y also increases. Okay, so let's use the correlation function correlation between sales and YouTube. We have to indicate the data set from where it's coming, because we did not attach the data set marketing a while ago. So let's just use this correlation. Although we already know the answer here, it's 0.7 something there, 0.78224. Let's plot this again, the GG pairs. There, 0.782. Okay, we got this a while ago. So I just generated this using the core function. So it's a correlation between sales and your YouTube. Okay, then here are some explanations. A value close to 0 suggests a weak relationship or no relationship between the variables. And usually the benchmark is if it's between 0.2 and -0.2 and 0.2, it means that there's a weak weak to no relationship between the variables. In such a case, we should probably look for better predictor variables. So that's why I said that it's best first to look at the relationship between your dependent variable and independent variable. In our case, you notice that YouTube has the highest relationship, 0.7 to 8. And then you have Facebook, which is around 0.5. And lastly, you have newspaper around 0.2 something. So among these three, as I said a while ago, newspaper will be the worst, okay, relatively the worst predictor compared to YouTube and Facebook. YouTube will be the best predictor by way of having a high correlation between YouTube and sales. Okay, we now go to the simple linear regression. Okay, Now, the simple linear regression tries to find the best line to predict sales on the basis of YouTube advertising budget. Okay, so we're first going to look at YouTube independent from the other, from Facebook and newspaper, because we're just doing a simple linear regression. Okay, so how do we do simple linear regression in R? Okay, so we create an object here. Let's call it model. Okay, and then the function to be used is LM, linear model. So if you're doing regression in R, we use the function LM and then identify sales is your dependent variable Y. The tilde here says that you're regressing sales on YouTube. Okay, take note, we're only using one independent variable. And what type of regression is this? This is your simple linear regression, and the data is from marketing. So this is our code, guys. This is our code. Very simple, very easy to run regression in R. LM, which means your linear model. Sales is your dependent variable, and then tilde for your independent variable. Now, later on, not later on, because we will do multiple regression. Let me just point out that if we're including Facebook, for example, plus newspaper, okay, this will be how to go about this. So you're identifying the three predictors. If you have a case like this, then you have multiple linear regression. Okay, but since our lesson is only focused now on simple linear regression, we're just going to make use of one independent variable. So let me delete that. Okay. All right. So once again, guys, in order to create a linear model, so we create an object called model. It's best to give a name to it and use an intuitive name, like just model for me. And then LM. What's the meaning of LM, guys? LM means linear model. And then the code requires that we first identify your dependent variable, and then tilde, and then your independent variable. Now we're only considering YouTube here as a predictor of sales. So this is called simple linear regression because we're only using one independent variable. In the next session, we're going to use multiple linear regression. So we're going to add here Facebook and marketing. So let's run this. Run. Okay, so that means here in your object, in your environment, you have already model. And you notice that there are 12 objects inside this model. Okay, so let's ask R to generate an output called summary. Let's run this, just the summary first. Let's run ANOVA later. Summary. All right, so let's take a look at this, guys, because this is now the heart of the output in linear models. Okay, so first, R is restating here the model that we're using. It's a linear model where your sales is regressed on YouTube. Data is from marketing. And then here you have the basic stat for your residuals, the minimum value of your residuals. Residuals refer, guys, to your error terms. Okay, error terms. Where do you get the error terms? Well, the error terms come from your actual value. Okay, so if I take a look at this, you have sales here, right? You have sales here. Okay, and then we have actual value. This is your actual value, and then you'll have predicted value. And then you have the difference between your actual sales and then your predicted value is your residuals, which we're going to show in a while. All right. So the minimum of your residuals, the first quartile, and the maximum are these. Okay. So those just give us the some values about your residuals. There, guys, let me drink water. Okay. And then we have the coefficients. Okay, this is very important, guys. This output, this is now the test whether our predictors or coefficients are significant. Okay, remember guys, what's our model? Let me write here again. We're modeling Y sales. Okay, it's equal to B null plus B1 times your YouTube. Okay, so this is our model. Y sales is equal to B null plus B1 times YouTube. Okay, first let's take a look at our coefficients. Intercept is B null, guys. That's your 8.439. This is your intercept. So this is the value of your sales when YouTube is equal to 0. Okay, because if you substitute YouTube with 0, then it doesn't matter what the value of B1 is, this will still translate to 0. And then you're left with Y sales is equal to B sub 0. Okay, so B sub 0, the intercept, is the value of your Y, which is sales, when your independent variable is 0. So if YouTube is equal to 0, then your sales will be 8.439. Okay, we'll discuss that in greater detail later. All right. So the question is, this guys, this is coming from a test. Okay, let me refer to our test here on top. Okay, this one. Where is our test? This one. Sorry, not yet. Sorry, I didn't write it. Okay, so let me write it here. We're testing the coefficients. Okay, so number one, our null hypothesis is that B0 is equal to 0. And another null hypothesis, B1 is equal to 0. Okay, so take a look at this test, guys. B0 is equal to 0. Okay, what's our conclusion? We base our conclusion on the t-value or the probability, the p-value. Okay, here the p-value is, it's practically 0. It's 0.00002 something, 15 zeros, and then 2. Okay, right? So that's practically 0. Okay, so what's our conclusion? Our conclusion is, okay, we reject the null hypothesis that B0 is equal to 0. With P value is equal to 0.000. Let me just put that at 3 decimal places. Okay, where did I get 0.000? From this one, guys. Because this one is actually, if we're going to write that, that's actually 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 2. Okay? So that's actually your P, guys. Okay, so that's practically 0. And the decision rule is that when P is less than the usual level of significance is 0.05. So the question is our p-value for the intercept for B null equal to less than 0.05? Yes. Taking a look at this, guys, this is less than 0.05. Okay, therefore, we say that when the p is low, when the p is less than 0.05, then we reject the null hypothesis. So usually when the p value is low, what do I mean by low? Less than 0.05, then the null okay, let me I just wrote that as an informal statement because I find it easy to remember this. When the P is low, the null, this is your HO, the null must go, okay? So again, for the intercept, guys, what's our null hypothesis here? The null hypothesis, the intercept is your B sub 0. The null hypothesis there is B sub 0 is equal to 0. Now, how do you determine whether this hypothesis will be rejected or will not be rejected? We look at the p-value, or the t-value can be, but you have to know the t-critical value. So for the p-value, guys, the value of the probability that your B sub 0 will be equal to 0, that probability is equal to 0.00000, etc. 2. So that's a very, very low probability. Again, the probability that your the value of your B sub 0 is equal to 0 is practically 0.000, etc. It's practically 0. So what's our inference? What's our conclusion? We reject this null hypothesis that P sub 0 is equal to 0. Okay? As I said, when the p-value is low, when we say low, it's less than 0.05, then the null must go. Okay? We have to let go of this, which means we reject that null hypothesis that B sub 0 is equal to 0. P is equal to 0.00, which is less than 0.05. Okay? Clear, everyone? Pwede mag-comment o magtanong, ha? Kahit tayo asynchronous, I'll entertain questions. Clear so far?
Yes, sir.
Okay, thank you. Now, in next, guys, ito naman i-test natin. Yung ano natin, yung independent variable. YouTube. Okay, YouTube is B1, no? B1. So our null hypothesis there is B1 is equal to 0. Okay? So what's our p-value? Ganun din, pareho rin, no? Very small, no? So, anong conclusion natin dito? Control C, Control V. So we reject the null hypothesis that B1 is equal to 0 since P is practically 0 and it's less than 0.05. So both parameters, both coefficients are significant. Intercept at saka si YouTube. Okay, now take note, guys. Because of that, we can now create our model. Okay, so here, okay, sandali, yung model muna natin. Ito na pala. Okay. So, siguro I should put this here. Okay. So let's go here, guys, to the interpretation first. We'll go back to the codes that we missed. So from the output above, the estimated regression line can be written as sales is equal to 8.44 plus 0.48 times YouTube. Okay, where did that come from? 8.44 came from this one. Okay, so we're rounding it to the 2 decimal places. 0.048 is from this one. Okay. Now, why did we include 0.048 in our model? Because we're able to show that this one, the YouTube, this estimate is significant. The probability that this is equal to 0 is this one, 0.0000002, etc. Right? So the probability that this is 0, that your coefficient YouTube is equal to 0, is 0. It means that it's not possible for it to be 0. It is a value other than 0. So that's why here we're saying that we reject the null hypothesis that B1 is equal to 0. In other words, YouTube is statistically significant. So we can use that in our model. And so is intercept. We can use this in our model. Hence, our final model, guys, is, as we were pointing out, this is our final model. Our sales is equal to 8.44, which is your intercept, plus 0.48 times YouTube. Okay, so let's give a meaning to this. The intercept beta null is 8.44. How do you interpret that? As I said a while ago, guys, it can be interpreted as this is the predicted sales, or this is the value of sales, your dependent variable, when your independent variables are all equal to 0. But what's our independent variable? Our independent variable is YouTube. So we're saying that sales is equal to 8.44 when YouTube is equal to 0. Okay, now, of course, take note, guys, what's the data that you have. In our case, the sales is in, okay, sales is in $1,000, okay? Thus, for a YouTube advertising budget to be equal to 0, we can expect a sale of 8.44 times 1,000. Okay, so sales is in thousands of dollars. Okay, so what does this tell us? What does this tell us, guys? That the expected value or predicted value of sales when your YouTube, when advertising budget for YouTube is equal to 0, is $8,440. Okay? Clear, guys? All right. So my question is that a reliable estimate? Is that a reliable estimate of sales when your YouTube budget is 0? Now, to answer that, okay, let's run this summary of marketing. Okay, to answer that, if you take a look at YouTube, guys, what's the minimum value of YouTube? 0.84. What's the maximum? 355.68. Okay, question. What value of YouTube budget are we using to predict sales? It's what? It's 0. Why? Because for the intercept, how do we interpret the intercept? The intercept is the value of your dependent variable sales when your independent variable YouTube is equal to 0. Okay? So in order to answer this question, is this a reliable statement? Okay, we take note of the concept of the relevant range. Kasi we have predicted sales based on a minimum value of YouTube of 0.84 and a maximum of 355.68. So this means that 0, the value of YouTube is equal to 0, is outside this relevant range. Kasi the minimum is 0.84, tapos the maximum is 355. So it's outside that relevant range. So ibig sabihin nun, guys, we cannot put so much importance or put so much interpretation to that value of sales when YouTube is equal to 0 because it is outside the relevant range. Okay, clear? But why do we still compute it? We still compute the intercept because we can use that to predict the value of sales for values of YouTube that are within the relevant range. Do you get me, guys? Okay, what do I mean by relevant range? The minimum value of YouTube is 0.84. The maximum is 355.68. So that's the relevant range. In other words, guys, you can only use your model when your value of X or YouTube is within the minimum and the maximum. Or it can be outside, but it's close, very close to your minimum or your maximum. When the value of X is way beyond this minimum and maximum, then you're not certain about your prediction. Because take note of the concept of relevant range. We came up with this model, this one. This model of your intercept and your slope for YouTube within the relevant range, 0.84 and 355.68. So if you're going to predict sales and the value of your YouTube that you're using to predict sales, for example, what is the predicted value of sales if YouTube is equal to 1,000? Oops, teka muna. Yung YouTube na yan na 1,000, okay, pwede ko bang pwede ko bang palitan yung YouTube dito, gawin kong 1,000? Mathematically, guys, pwede kasi equation yan eh. if you substitute this with 1,000, then you can get a predicted value of sales. But how certain are we of that? We cannot be very certain. Okay, kasi guys, outside the relevant range siya. So dapat tingnan natin ano ba yung minimum value ni YouTube at saka ano yung maximum value ni YouTube. So makakapag-predict lang tayo dyan sa range na yan. Relevant range, guys. Okay? Kung yung YouTube na value na ginagamit natin pag-predict is way outside that value, this relevant range, hindi na tayo magkakaroon ng let's say kahit papaano confidence sa prediction natin. But if we're predicting the value of sales and it's within the relevant range ng YouTube or kahit outside, a little bit outside, okay lang yun. Huh? Okay so far, guys? Okay. So, na-explain natin ano yung 8.44. Ano sabi natin, guys? 8.44 is the value of your sales when your independent variable is 0. Kasi, papalitan natin si value ni YouTube. If we replace this with 0, then 8.44 yung lalabas. Okay, anong tanong, guys? Ang tanong ko, paano kung hindi significant si intercept? Kunyari, ang p-value niya 0.08. Okay, 0.08 yung p-value niya kunyari. So ibig sabihin nun, it's greater than 0.05, no? Therefore, gawin ko dito if b sub 0, if yung b sub 0 is equal to what if p value is greater than okay. In this case, guys, ano mangyayari? We reject yung HO that we fail to reject the null hypothesis that b sub 0 is equal to 0. Okay, there's strong statistical reason to believe that your intercept, your b sub 0 is equal to 0. However, guys, practice is that b sub 0 is 0. Okay. All right. So, ang practice yan, guys, kahit na hindi significant, kunyari, si intercept natin, lumabas na 0.08 yung probability niya. Okay, so ang conclusion natin nun, guys, we fail to reject the null hypothesis that b sub 0 is equal to 0. Ito kasi null hypothesis natin, na si intercept daw, b sub 0 is equal to 0. So if the p-value turns out to be 0.08 or any value higher than 0.05, then hindi natin mare-reject to. So your b sub 0 will be equal to 0. Okay, guys? All right. Now, and then I said here na kahit na, guys, yung b sub 0 is not significant, sinasama pa rin natin yan sa model natin. Okay, this is our model. We still include that in our model, this one. Kasama pa rin to. Okay, next. Ito na tayo sa yung B1. What's B1, guys? B1 is this one. The coefficient for YouTube, 0.0475. Okay, how do we interpret that? First, is it significant? Yes, it's significant. Okay? Unlike, guys, yung intercept, kapag hindi significant, pwede natin isama sa model natin. Yung independent variable, guys, yung regressor, kapag hindi significant, hindi natin sinasama yan sa model natin. Okay? But in this case, your YouTube turns out to be significant, a significant predictor of sales. And the value is 0.047. Okay, so how do we interpret that? Kailangan ma-interpret natin, guys, yung 0.0847. Okay, and it's here. Sinulat ko dito para yung reference niya. The regression beta coefficient for the variable YouTube B1, also known as the slope, is 0.048. This means that, okay, so how do we interpret that? Paano guys? Kasi yung ano natin, advertising natin in thousands eh. So let's interpret it that way. No? For a unit change, okay, in advertising, in YouTube advertising budget, there's a corresponding what guys? There's a corresponding 0.48. So that's equal to 480. Okay. Okay, so let's go back here. Ano yung value ng ano? 0.048. Okay. So 0.048 siya. So ang sabi natin dito, pag nag-increase daw si YouTube advertising budget ng okay, hold on ha. Ganito muna gawin natin. Okay, sorry for this. Ano ibig sabihin nito? 0.048. Ibig sabihin nito guys, for every 1 unit increase in YouTube, there's a corresponding 0.048 units increase in sales. Let me repeat that. For every 1 unit, okay, increase in YouTube advertising budget, there's a corresponding 0.047537 units increase in your sales. Okay, so take note how do you interpret this? Kinuha ko muna yung 1 unit increase in the independent variable which is YouTube, and then related it with the 0.047 units increase in sales. Okay, since the advertising budgets are in thousands, i-multiply natin ito ng thousands, no? So 1, 2, 3. Ang ibig sabihin nito guys, for every $1,000 increase in YouTube advertising budget, there's a corresponding 48.5 dollars increase in sales. So pag nagtaas daw ng YouTube advertising $1,000, sales will increase by 48.5537 dollars. Okay, clear yung guys? Clear? Clear ba?
Yes, sir.
Okay, so thus, sabi ko dito, okay, for a YouTube advertising budget equal to 0, so babalik tayo dito kanina, no? Kasi pag 0 daw yung YouTube, okay, ang sales natin will be 8.44, or if you multiply that by 1,000, it will be $8,440. Okay. Wait, sorry, ito pala, no? Sorry. Okay. So sabi natin yung regression coefficient natin si B1 is your slope 0.048. This means that for YouTube advertising budget equal to $1,000, okay, ito guys, YouTube advertising, ito yung sinasabi ko kanina, no? 1,000. Pero palitan na lang natin ito ng kasi outside din siya ng relevant range eh. So let's change this by, let's see, $200, okay? We expect an increase of 0.048 times 200. So what's this? 16, 31, 96. Okay. Now, pwede natin gamitin yung $200 kay YouTube kasi it's within the relevant range. No? So, kasi when we modeled when we did our linear model, guys, in YouTube natin, range from 0.84 to 355.68. So kanina, I replaced the example kasi outside the relevant range yun eh. Dapat kung even nag-exceed sa maximum, dapat hindi masyado nalalayo. No? So we can expect an increase of 48 units, okay, times 96 in sales. That is sales is equal to 8.44. Okay, this is 200. So that's 8.44 plus 96. Eight 8.44 plus 96. 104.44. 8.44. Sorry, mali yata ako. 0.048 times 200. Sorry, 9.6 lang to. 9.6. So this should be 9.6. $18.04. Okay, sorry for the correction. I forgot that I forgot to consider a relevant range, no? Kasi predict natin si sales using YouTube of 1,000, eh masyado malayo siya dun sa sa relevant range ni YouTube, guys, no? So we cannot use that kasi hindi natin alam kung ano yung behavior ng sales kung masyado na malaki si YouTube. Yung model natin, we only use this relevant range. So we can only predict kung medyo malapit dyan sa relevant range yan. Kung in between that or kung outside that, medyo malapit naman, no? Okay, so balik tayo dito, guys. Okay. Sorry, medyo hindi dapat re-arrange ko to. Okay. Now ito. Okay, let's take a look at this, guys. Hindi pa natin itong narantong ANOVA, no? So let me run the ANOVA, yung tatlong to. Okay. So ito yung kanina, yung LM natin, ito. And then meron pa tayo nadagdag dito, analysis of variance. Yan. Okay, so just to explain this, guys, okay, ano itong analysis of variance? Yung ANOVA, guys, ang null hypothesis yan, sinulat ko na dito. Yan. The null hypothesis there is beta null is equal to beta 1 is equal to 0. Okay? So how do we determine kung ano yung inference natin dun? Our answer is that, based on the ANOVA, ito din yung p-value. Notice that this is quite different from the regression output. Ito, no? Iba siya. No? Ito, tinitingnan natin yung significance ng individual parameters. Ito, tinitingnan natin yung overall goodness of fit. This is called the overall goodness of fit test. And our null hypothesis there is, ito yung null hypothesis natin dyan. Ito. Overall, lahat tinitingnan. B null is equal to B1 is equal to 0. Bakit dadalawa lang? Kasi simple regression lang tayo. B null is your intercept, B1 is your slope for YouTube. Okay? And then what's our conclusion? Conclusion natin, guys, titingnan ulit natin dito sa probability, no? The probability is practically just like the individual coefficients a while ago. Yung p-value na yung p-value natin dito is 0.00, 3 decimal places. No? So our conclusion is we reject the null hypothesis that B null is equal to B1 is equal to 0. Okay? So reject natin yon. No? Ito. Ano yung conclusion natin? At least one of these parameters, either B0 or B1, is not equal to 0. And we have shown that, guys. We have shown that B0 is equal to 8.44 and that it's statistically significant. It's not a value equal to 0. And then this one also, see YouTube, 0.047537. It's also statistically significant, which means it's a value. We are certain that this value is not equal to 0. Okay, any questions, guys?
None po.
Okay. All right. So, ang importante, guys, naiintindihan natin kung paano i-interpret to. Ito yung coefficients natin. And here, yung coefficients natin. Ito, iisa lang yung coefficient natin kasi simple regression to. So next meeting, madadagdagan natin to. No? Tapos tingnan natin kung paano i-interpret kung marami yan. That's multiple regression. Okay, kasama pa rin yung intercept. Okay, so moving forward, guys. Now, once you have created your model, may model na tayo. Ito na, no? Ito na yung equation natin. Y sales is equal to, asan yan? Y sales is equal to ito, 8. Lagyan natin to Y. Y sales is equal to X times YouTube. Okay, this is our equation. Okay. Now, we have already generated our model. Tapos na ba yun? Hindi. Kailangan magkakaroon tayo, guys, ng diagnostics. Ano yung diagnostics? Checkin natin, guys, yung model natin kung sinusunod ba niya tong mga assumptions natin. Kasi pag hindi sinusunod yung assumption, guys, magkakaproblema tayo. And it's all about testing your residuals, yung error terms natin. Okay? Okay, ano ba yung error terms? Pakita lang natin, ha? Okay, so nag-generate na tayo, di ba, ng object na model. Ito yung model natin. Okay. If we take a look at this, itong model, if I click this, ayan, no? Model, guys. Ano laman ang model niyan? Ang sabi, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. Si model, guys, yung model na object, meron siyang labing dalawang laman. No? 12 objects inside the model object. So, andyan yung coefficients. Ang coefficients daw, dalawa yung laman. No? Andyan si residuals, andyan si effects, andyan si rank, fitted values, 200 yung laman, etc. No? Okay, well, lahat importante pero ang titingnan natin, una, itong coefficients, bibigyan lang yan B null at saka yung B1. Tapos si residuals, guys, ito na yung error terms. Ito na yung difference ng actual value at saka ng predicted value. Tapos ito naman yung fitted values, guys. Ito yung predicted values or fitted values. Okay, balik sandali tayo dito, ha? Okay. So we're now here. Okay, so this is a command, guys. Names ng models. Yung generate kanina na yung laman ng mga object na yan, ito. Okay. Names ng models. Yan. So may coefficients and other objects. So ano yung coefficients, guys? Ano yung coefficients? Sulat ko lang dito, model dollar coefficients. Yan. Take a look at what I wrote here. So if I ask R to generate this, yung model, bigay mo nga sa akin yung coefficients. Enter. What do you have? Okay, so you see this, guys? Sulat natin dito, ha? let's inspect. So insert. And just copy this. Okay, let me reiterate this, guys. I said that the model object was generated dun sa linear model natin. Ito yun, di ba? So balikan ko ng konti. Ano yung model na yan? Ito. Sabi natin, we're creating an object called model. Tapos ang result niyan, yung LM, linear model ni sales, regress on YouTube, coming from data marketing. So sabi natin, yung object na model na yan, merong 12 laman, di ba? It has 12 objects inside it. Okay. So ano yung mga yon? Ito. Ito yung mga objects na yan. So sana siya? This one. Okay. Tapos sabi natin, tingnan natin kung ano laman itong coefficients na to. If we run this, okay, yan laman niya. Yung coefficients, yung intercept at saka si YouTube. Okay? Ano pa? Okay, let's also ask R to generate itong residuals at saka yung fitted values. Okay, so here, I'm creating an object. Okay, nag-create ako ng object called predicted. And ano siya, yung model fitted values. And i-view natin. So let's see. Okay, ito guys. Ito. So these are your predicted values. Balikan natin to next meeting to. And we're going to analyze this in greater detail. Pero ituloy ko na muna para at least umabot tayo dun sa sa ibang parts, no? And also we can generate the residuals. Ito. If you run this, okay. Right? So I leave you as an exercise, guys, to create an object na magkakasama sila. Tapos, kasi, okay. Let me just show you, ha. Okay, ito yung sales natin, guys. Sales. Okay. So what was our regression model? 8.44 plus 0.048 times YouTube, di ba? So for a sales of 26.52, for YouTube equal to 276.12, ano yung predicted value? Kuha nyo, guys. Sulat natin dito. Dito na lang. Okay. Just to show you guys, ito yung intercept natin. All right, take a look at this. Ito. Ano to, guys? Check the predicted okay. Ano ba yung first observation natin sa data natin? Ang first observation natin is YouTube is 276.12. So I copied that, kinopy ko siya, no? Kasi i-generate natin tong equation natin. Yung equation natin na B sub null plus B sub 1 times YouTube. Ito yon, guys. 8.439, ito yung ano natin, kinopy ko dito sa intercept, plus B1 times YouTube. Saan ang galing to, guys? Saan ang galing to? Saan ang galing to? Where YouTube is equal to 276.12. Okay? So yung sa unang observation natin, yan, si YouTube 276.12. Okay. So let's use this 276.12 para ma-predict natin si sales using our regression line. Okay, I hope you're getting me, guys. Ano ba yung regression line natin? Beta null plus beta 1 times x, no? So beta null is this one. I got this from the intercept plus beta 1 ito, no? Times YouTube, no? Di ba yun ang model natin? Clear ba, guys? Clear ba? Hello? Wala na yatang ano.
Yes, sir.
Okay, thank
Yes,
you.
sir.
Thank you. Of course, I don't expect an answer kasi asynchronous nga pala dapat to, no? Anyway, so, sige. Binalikan ko na equation natin ito. Let me copy this. Control C para clear sa atin itong ano. What I'm doing is I'm predicting the value of sales. Kasi si sales ang pinipredict natin eh. Okay? Tanggalin ko lang itong X dito kasi nakakalito. Okay, Y sales is equal to, okay, let me copy this. Ito yung buong ano, Control C, Control V. That's the whole number for your intercept. Tapos ito, Control C, and then Control V. Yan. So that's our equation, guys, no? Okay, so we use that in order to predict our sales. So Y sales is equal to the intercept plus the slope of YouTube times the specific value of YouTube. So ginagamit ko dito yung unang observation natin ni YouTube. And then if I generate that, guys, the predicted value is 215469, no? Okay? So if we take a look at the predicted table, ayan, no? 21564929. May decimal places lang na nadagdag, no? But it's the same, guys. So ito yung predicted value natin. Okay? So how about the error term? Salin natin dito. So the error term for observation number 1. Okay. So what do we need? What do we need, guys? Okay, number 1, actual sales natin. What's our actual sales? Ang sales natin 26.52, no? I'm just showing you 26.52. Okay. And then what's our predicted value? Our predicted value is ito, di ba? 21. Control C, Control V. Yan, that's our predicted value. So the difference between that, guys, is your residual. So actual value, Control C, formula natin, actual value minus your predicted value. Yan. So actual, lagyan natin dito, lagyan natin ang ano, actual sales minus predicted sales. Okay. So yan, that's how you compute for your residuals, guys. May na-generate tayong model, kukomputin natin ngayon yung predicted value or fitted value ng sales natin based on the model. And then, we also have an actual value. I-compare natin yun. No? Tapos, kunin natin difference sila. Control, Enter. And then you have 4.955. No? Tingnan natin yung residual natin. Ito. Yung una ba, ano? 4.955. Yun. Eksakto, guys. Eksakto. Diba? So that's how you generate your residuals. No? Okay? Ulitin ko lang ha. May mga actual values tayo, actual in sales. Tapos ginamit natin si YouTube para i-model si sales. Nagkaroon tayo ngayon ng regression line. Ano yung regression line natin? 8.44 plus 0.048 times YouTube. Okay. Based on that equation, pwede natin i-predict si sales. Paano i-predict si sales? So gagamitin natin lahat ng mga YouTube values, yan, yung mga yan, no? Yan. Those actual YouTube values, you replace it to the model. And what's the model, guys? Again, what's the model? Ito yung model natin. No? So papalitan natin si YouTube dito ng lahat ng mga values ng YouTube na actual. Ito, papalitan natin lahat yan. So you're going to generate your fitted values or your predicted values based on the model. Okay. Next meeting, guys, is superimpose natin dito yung predicted at saka fitted, no, para kitang-kita nyo. Gusto ko, guys, I leave that as an exercise. I-discover nyo, guys, kung paano natin isasama dito sa marketing natin yung predicted at saka yung fitted. No? Yung predicted tapos yung fitted. Okay? I leave that as an exercise and then compare natin next meeting. All right. So we were able to prove, indeed, nakuha natin yung predicted value at saka yung fitted value. Okay? All right. Then importante, guys, yung mga values yan, particularly the residuals. Kasi ito na yung tinitingnan natin for ito na dapat yung sum niyan dapat dapat yung sum niyan 0, no? Okay? Alright. Sample natin, ha. Tingnan natin. Dito na lang para mabilis. Sum ng model under. May object na tayo, di ba, na predicted. Ano yung sum ng predicted? Hindi, sorry. Not predicted, but the received. Okay, hear nyo, guys. What did I do, guys? Sinum up ko yung mga residuals. Ito. Pag sinum up natin yan, guys, the value should be equal to 0. So that's practically 0, no? 0 yan. No? So tama tayo. Kasi isa yan sa assumption ng classical linear regression model. Yan, ito. The error term has a population, the sum of the error term is 0 and then the mean is 0. So kunin natin yung mean para mean ng receipt, average. Okay, yan, guys. Ano yung mean niya? Ano yung average ng ng residual? 0, guys, 0. So tama tayo as far as the assumption of OLS assumption number 2. The mean of the residual is 0. Okay, kasi pag hindi 0 yan, guys, mali yung model na yan. Okay, so I have some more minutes, guys. Dinagay ko naman dun 11 to 1. Guys, if you need to leave, you can, kasi naka-record naman to. So I just encourage you to view this again. Okay, now, yung ginamit natin to view our model is yung summary, no, kanina. Okay, summary. Now, there are other ways to present your regression model. I find JTools to be good and the Stargazer. So, yung sum SUMM na to, summary function, galing yan kay JTools package. Tapos yung Stargazer, galing yan kay Stargazer package. So, these are two different ways. Aside from this one, yung kanina, yung regression output natin. Sorry to keep on vacillating between the different outputs. Ito. No? Ito yung individual test for the individual coefficients. And then ito yung yung ANOVA test. Okay, hindi ko pa na-discuss, guys, yung adjusted R-squared. Kailangan natin ito i-discuss. So let me discuss that first before we go to the other forms. Okay, so here, okay, may linagay ako dito, guys, no? Ito. Yung ANOVA output nga lang natin kasi ANOVA output natin. Ito, no? This one. So let me copy this. Let me copy this here. So copy of ANOVA output above. Okay, so take a look at this, guys. Ito yung ANOVA output natin. Now, there are some numbers here that we need to understand. No? Okay, ito, degree of freedom. Saan nanggaling itong degree of freedom na to? So the degree of freedom, number one, ito, is the degree of freedom of your regression. And it's equal to the number of regressors. So ilan ba yung regressors natin? Ilan yung independent variable natin? Isa lang, si YouTube lang. Okay, so kaya 1 yan, no? 1. Pwede ko pa rin sulatan. Pangit kong sulatan eh. Gugulo yung output. Okay, anyway, so degree of freedom. So YouTube, or this is called your regression kasi yung independent variable natin si YouTube. Okay, and then the residuals, the degree of freedom of your residuals is dito. Degree of freedom of regression is equal to number of predictors. In this case, it's only df is equal to 1. Only one predictor. Okay? Okay, there's another degree of freedom na kailangan natin. Degree of freedom, let's call this 1. 1, degree of freedom 2 of residuals. And it's equal to n minus k minus 1. And it's a number of observations minus number of regressors minus 1 to account for intercept. Okay. So, binibilang natin guys yung degree of freedom ng residuals and it's equal to n minus k minus 1. Ilan ba yung n natin? Ilan yung n natin guys? Number of observations. Our n is equal to 200. No? Kita natin dito yan sa ano, sa dito for example sa here. Yan, no? Sa marketing natin, 200 observations. So saan na ako? Okay, medyo okay, n. Okay. So we have n minus k minus 1 is equal to 200 minus k, which is 1, which is your number of regressors, minus 1. That's for your intercept. Kasi i-predict din natin intercept and we lose one degree of freedom by predicting the intercept. So 198. So that's where you got this, guys, 198. Okay? All right, next. This is sum of the squares. No? Sum of the squares. This is the sum of the squares of your regression. Ito yun. Ito yung regression natin, ito yung residuals natin. Other softwares will generate another one here, total. Total and degree of freedom is 199. Sa Excel, meron pa yan. Then, and then the sum of the squares of the total is just the sum of, so this is 800.7. Okay. Asan yan? 7. Okay. So this came from, okay, wala. Wala natin dito. Sorry, SSR is equal to SS, sum of the squares, guys. Yung SS dyan, ibig sabihin ito. Sum of the squares of your tatlo yan. Sulit ko na. Sum of the squares of regression or SSR, and that's equal to this one, guys. SS to SS, no, sum of the squares of YouTube. YouTube is your regressor. Okay, so that's 4773.1. Control C, Control V. And then sum of the squares of residuals, your SSE, okay, or error terms, no? Slash errors. That's equal to, let's copy this. Control C, Control V. Okay, and last, sum of the squares of total is equal to SST, which is equal to SSR plus SSE. Okay. All right. Sorry for having to discuss this. Ito na yung anatomy kasi, guys, ng regression. Eh. Kailangan na iintindihan natin bawat isa dito. No? We have to understand what's happening here. Okay, and then we have to know how to interpret this. Okay, ano muna yung SS, SST, guys. SST. So how did we compute for your SST? Si SST is yung actual value natin minus the average. Okay? So yung SST, guys, ang mangyayari dyan, parang hindi natin gagamitin si YouTube to predict the values of sales. So paano natin malalaman yung mga errors natin dito? Okay? Actual sales minus the average of your sales. In other words, guys, we're just going to use the average of sales as a benchmark. Okay? So kung titingnan natin dito, guys, kunin natin yung average ng sales. Tapos, each of the values here, sales minus average, 12.48 minus average, 11.16 minus average. And then, square natin bawat isa. Square natin bawat isa. Okay? And then, sum it all up. Ang tawag doon, total sum of the squares. Or sum of the squares total. Okay? Now, ang next dyan, itong sum of the squares of your regression. How do we get that, guys? How do we get that? So sa regression, gagamitin na natin si YouTube. Gagamitin na natin si YouTube to predict our sales. So mag-i-improve yung natin, yung model natin. Dati ang lang natin, ang ginamit natin si average lang ni sales. Ngayon naman, gagamitin natin yung predicted value ni sales, tapos i-compare natin siya sa average ni sales. Okay? Yung improvement o yung difference ng predicted value from the mean is called your sum of the squares of your regression. Okay, so ang ginawa natin yung average ni sales minus predicted sales. Okay, di ba 200 yan? 200 yung data points na to. Kasi bawat isang observation may prediction tayo eh. Tapos i-square natin. The value that you're going to get is your SSR, sum of the squares of your regression. Okay, next meeting siguro papakita ko sa Excel para visually kita natin. And then, lastly, sum of the squares of your errors or your residuals. Ito yung sales minus predicted sales. Okay, alam natin to, no? Your actual sales minus your predicted sales, those are your residuals, tapos i-square natin. Okay? So, importante itong total na to sa atin. Kasi, kung tutuusin, guys, tingnan mo, may papakita ako sa yung formula. What is SSR divided by SST? Ano to? Sige nga, guys. What's your SSR? Dapat mag-insert tayo ng SSR is what? SSR regression is this one, di ba? Control C. Where is that? Asa na? Ayan, okay. Control V. SSR divided by, what's our SST? Ito na lang. Okay. Yan. 611881. Ano to guys? Ano to? SSR over SST. Sum of the squares of your regression divided by sum of the squares of total. Let's see guys, sa ANOVA output natin. Ano yun? Okay. Kita niyo ba dito yun guys? Yung 611.611? Okay, ito siya. R squared. Okay. As I said guys, saan ba tayo papunta? Kailangan maintindihan natin yung anatomy nitong regression output na to. Kasi pag naintindihan natin to guys, kahit ano regression, iba to sa atin, maintindihan natin yan. So that's why I'm painstakingly really looking at these items, no? I was tempted to use first Excel para mas pero sabi ko diretso na lang sa R na mismo. Okay, so ito yun And how does that compare with this one? Pareho siya guys. Okay, so this is called equal to R squared. Okay. So importante sa atin yung R squared. Kasi what does 61.19 mean? It means that around 61.2% of the variation of the DV sales can be explained by your IV YouTube. Okay, yan. Yan ang ibig sabihin guys ng R squared. R squared. And that's called your, okay, it's called your equal to coefficient of determination. Okay? It's called your coefficient of determination. Ang sinasabi niya na yung SSR natin, 4773, divided by the total, 7800, 61% and 62%, ibig sabihin yan, kayang i-explain ng independent variable natin na si YouTube, yung variation ni dependent variable. So is that good? Yes, guys, the higher the R squared, the better. No? Kasi kung mas mataas yung R squared, ibig sabihin mas kayang i-predict or mas kayang i-model ng independent variable natin, yung dependent variable natin. I leave you guys to exercise. Gawin nyo to this time for Facebook. Tapos i-compare nyo R squared. Definitely guys, mas maliit yung R squared ni Facebook kasi una-una yung correlation nila, di ba? Hindi masyadong correlated si Facebook to sales compared to YouTube to sales. Lalo naman si newspaper. Kung titingnan nyo mas maliit yung R squared, yung R squared which is the coefficient of determination ni newspaper to sales. Alright? Okay, so importante sa atin guys, intindihan natin itong SSR, SSE, and SST. Sum of the squares of your total, sum of the squares of your regression, and sum of the squares of your error terms. The higher the ratio, the ratio is, the better. So it means guys that, ano implication nun? So 1 minus this, so 1 minus that, 38%, 38.89%. Ibig sabihin nun, yung hindi kayang i-explain ng model, 38.8%. Ang kaya niya i-explain, 61.19%. Ulit, ang hindi niya kayang i-explain, ang hindi kayang i-explain ni YouTube about sales is 38.81%. Ang kaya niya i-explain, 61.19%. Kasi dapat 100% yan. Okay? All right, so, okay, a few more here. Okay. I'm happy guys, marami tayong na-discuss, no? So just a few more minutes. Okay, so ito pinaplot lang ulit guys yung regression line just to parang rinido lang natin nasa taas. Ito. Okay. Ito yung regression line natin. Ito yung mga actual data points. So guys, yung difference nito, kunyari itong point na to, pag i-project mo siya dito sa blue line na yan, yun yung residual natin. Okay, so nakikita natin na may mga residual tayo na talagang malalaki, may mga residual din na maliliit, close to this. We want as much as possible sana yung model natin to our actual data points to be very close to our model. Pero guys, yung OLS, yung model na ginagamit natin, that will always give you the best line. Kaya nga tawag sa kanya also, the line of best fit. Okay, so pakita ko lang sandali. Hindi ko pala nakita ito kanina, sorry. Send ko na lang din to guys. No? Itong, can you see this? Yung PowerPoint? Baka hindi. So let me just share that. Okay, I forgot to mention this, no? Na how is beta null and beta 1 determined? Kasi kunyari, yung mga actual data points natin, there is only one unique line, okay, that will determine the OLS. Isa lang yan, hindi pa pwedeng dalawang lines yan. So unique yung beta null at saka yung unique yung slope ng beta 1. And that combination of beta null is beta 1 is determined by making sure that the residuals, yung residuals, no? Yung residuals, yung deviation niya o yung difference niya, yung actual data point from your predicted line. Okay? Remember, pag kinuha natin to, tapos in-square natin, pag sinum up natin yan, yan yung SSE yan. No? So dapat yung summation ng SSE, sum of the squares of your error terms, it should be at a minimum. Okay, dapat minimum yan. Isa lang yung line na yan, guys. It's a unique line. Kasi kunyari, dito natin linagay yung line natin. Pag dito yung line, tignan yung mga residuals, ang lalaki ng mga residuals yan. Okay? So, sorry, I failed to mention that a while ago. All right, so just to close this, okay, to close this, guys, now, hindi pa tapos yung ano natin, hindi pa tapos yung task natin. It's not enough for us to be able to determine your regression line, to determine your equation. Sabi natin, kailangan i-test natin yan for yung diagnostics natin. Kailangan i-test natin kung hindi ba vina-violate yung assumptions of classical linear regression model. Kasi kung vina-violate yan, dapat palitan natin yung model natin. Okay, so here is a code, guys, that will give us, so ito partition, okay, row, dalawang rows, dalawang columns. The plot model will give us the plot of the residuals. So basically, guys, ang tinetest natin yung residuals. Dapat kasi yung residuals, dapat homoscedastic siya, ibig sabihin dapat walang pattern. Kung may pattern yung residuals natin, hindi pa pwede yun. So, plot natin to. Okay, so this will give us four plots, residual versus fitted, normal quantile plot, scale location, and residual versus leverage. Okay, I already wrote here the notes, okay, on what those means. Okay, pakibasa to, guys, ha. Balikan na lang natin to next meeting. Pakibasa siya, okay? All right? And then you can plot this individually kasi medyo maliit yung ano, no? Maliit yung plot na to. Hindi ko makita yung number 179 at saka 36 yata. Those guys, those numbers are outliers. No? So kailangan natin i-investigate yan. So this one will show it individually. So ano ko to? Plot yan. Mas malakas, mas malaki, no? So we have here 26, 36, and 179. Ibig sabihin nito, outliers to. Okay, anong plot to, guys? This is a plot of your residuals, okay?
Sir, are you sharing your RMD screen, sir?
Ay, sorry. Thank you. Thank you, Shi. Okay, sorry. Yan, kita na?
Yes, sir.
Okay. So sabi ko kanina, balikan ko lang yung sinabi ko kanina, no? So itong plot na to, guys, itong code na to will give us this plot. 2 by 2. Kasi ginawa kong M matrix na yung row 2 by 2. 2 rows, 2 columns. Ano ipapaplot ko? Yung model. Plot model will give us this 4 plots. Tapos ito, individually lang to, no? Plot model 1, comma 1, ibig sabihin yung first plot doon. So ito yon. So this is a plot of your residuals, yung error terms natin, versus the fitted value. Okay, dapat guys, para okay yung model natin, para linear siya, at saka homoscedastic, dapat, yung red line na yan, dapat malapit siya dun sa zero line na yan. No? Yung dotted line na yan, where y is equal to 0. Kita natin medyo okay naman. No? So as far as linearity is concerned. Ang problema natin guys, yung homoscedasticity. Kasi dapat yung residuals na to, dapat ano siya, wala siyang trend. At saka tinan niyo to, parang yung fan, sa Tagalog ang tawag niyan guys, abanico, yung fan, siguro ginagamit ng mga lola niyo yan guys. Tinan yung behavior ng tumataas siya. So ibig sabihin hindi constant yung variance natin, which is a single that this is heteroscedastic. So pag heteroscedastic yan, kailangan i-remedy natin yan. Otherwise, hindi magiging, pag mag-predict tayo using the model, hindi magiging, it will become biased, hindi magiging acceptable. No? Okay? Itong mga numbers na to, 26, 36, and 179, these are the number of observations. So observation 26, observation 36, observation 179, they are possible outliers. No? Outliers sila. Okay, so pag may outlier guys, kailangan tignan natin yon. Okay? And later on guys, sa next meeting natin, titingnan natin yung outliers and influential. Kasi pwedeng maging outlier, pero hindi naman siya influential. Ang final verdict nan guys, yung influence. Kung influential data point kasi, ibig sabihin yan, pag tinanggal mo yan dun sa model natin, mababago yung yung regression model natin. So that's how influential that data point is. So ito, outlier siya, but we have to test kung influential ba siya. No? So nag-note ako dito guys, ito So please read this. Okay, the model does not meet the linear model. Okay, dapat i-check natin yung linearity and homoscedasticity. So paki-check na lang muna nito guys. No? Observation 179, tapos 26 and 36. No? Tatlo sila. Maybe outliers. Mache-check naman natin kung outlier sila. Tapos and then after outlier yung influence. Yung pangalawa guys, ito yan, normal quantile plot, normal QQ plot. This indicates kung yung kung yung residuals natin are normally distributed. Kasi yung assumption number 7 dapat normally distributed yung residuals natin. Mukha namang okay, pero may dito lang sa ang babantayan natin yung middle portion guys, no? Minsan dito nagkakaroon ng deviation. Okay? Pero itong 179, no, 36 at saka 26 talagang consistent sila. Investigahan natin 'yan, no? Okay, then the third one is scale location, no? Okay. Okay, dapat guys yung line na to, dapat flat 'yan, dapat horizontal. Pag medyo gumaganyan, ibig sabihin yan, oops, nako, mukhang heteroscedastic tayo. No? Mukhang hindi homoscedastic yung error terms natin. And dapat homoscedastic yung error terms natin. So medyo may problema tayo sa model natin. Okay, and lastly guys, okay, ito, number 5 muna. Okay, ganun din to guys. Dapat yung line natin, dapat nasa horizontal line na to. Tapos dapat walang pattern yung mga residuals natin. Parang walang patterns, no? Pero dun sa isa mukhang meron, may pattern siya. And ito guys, yung Cook's distance, this is to determine whether your outlier is an influence point. Dito na yan, sa number 4. Okay, ito. No? So mukhang may influence points tayo. Ito si 26, 36, and 179. I'll explain this next meeting. Alright, so yun na muna guys. Okay. We have covered a lot of things. No? Simple regression tayo, where we define the equation y is equal to beta null plus beta 1 times x. Okay, of course, may weakness kung iisa lang yung regressor natin. So next meeting, ang pupunta natin yung multiple linear regression natin. And we'll be able to show that mas maganda kung mas maraming regressors. Pero may limit yun, no? So ibig sabihin ba nun, mas maganda kung 100 yung regressors natin? Not necessarily. Kasi meron din tayong tinatawag na parsimony. Yung parsimony, kung pwede, mas maganda kung limited yung number of variables natin, pero mas na-explain na niya. Kaysa napakarami, tapos hindi naman yung iba nakakapag-contribute na dun sa pag-explain. Alright? So, I pause here, guys. Tingnan nyo na lang itong yung test for ito. Sige, run ko lang. Ito lang. Alright. Itong Bruce Pagan test, guys, will tell us kung homoscedastic yung error terms natin. Ang null hypothesis natin yan, the error terms are homoscedastic. Tapos yun yung p-value, guys. Less than 0.05. Therefore, our conclusion is reject the null hypothesis that the residuals are homoscedastic. Mukhang heteroscedastic na siya. Okay? So this statistically proves that your error terms are heteroscedastic. So ang next question, paano kung heteroscedastic yung error terms? Ibig sabihin hindi constant yung variance. Kasi dapat yung variance, kung tinan nyo guys yung night sky, tinan nyo yung sky paggabi, imagine na may pattern ba yun? Wala, di ba? Parang random siya na collection ng stars. Wala siyang pattern. Wala ka nakikitang trend na pataas or trend na pababa. That's an example of a homoscedastic residual. Ito ang sinasabi dito based on our figure a while ago and from the statistical test itself, hindi homoscedastic yung ano natin. Okay? Alright, lastly guys, multicollinearity, hindi siya significant kasi isang independent variable lang natin. Autocorrelation of error terms, hindi rin siya significant kasi itong autocorrelation, which is assumption number 5 yata or 6, it's only true if you have a time series and not a cross-sectional data set. Alright, okay, so tapos natin tong data set na to. Next meeting, we're going to continue with the multiple linear regression. Okay? So I end here. Maraming salamat guys. I'm going to post this later on. Thank you for those who came. Maraming salamat. And for those who were not able to come, of course you're not able to hear me, but I'm going to post this video later on. Okay, so unless there are any more questions. Yes? Sige. Thank you Thank you everyone. I'll see you on Wednesday kung pwede kayo. Okay, sige. Bye-bye.
Thank you, sir.
All right.
Thank you, sir.
Thank you.
Thank you, sir.
Bye-bye.